Morning to another person here. Introduction to fluid mechanics. First, we will go to discuss about the properties of fluids. Any characteristics of the system is called property. Some familiar properties are pressure, temperature, volume, and mass. Other less familiar properties include that viscosity, thermal conductivity, modulus of velocity, thermal expansion of coefficient, electrical resistivity, even velocity and elevation. The properties are called either intensive or extensive. The intensive properties are those that are independent of mass of the system, such as temperature, pressure, and density. The extensive properties are those whose values depend on the size and extent of the system. Total mass, total volume, total momentum are some examples of the extensive properties. Properties of fluid, that is density or mass density, specific weight or weight density, specific volume, specific gravity, and viscosity. The density of property, that is density of fluid, is defined as the ratio of mass of fluid to its volume. The mass per unit volume of the fluid is called density. It is denoted as a rho. The unit of mass density in SI unit, kg per meter cube. The value of the density of water is 1000 kg per meter cube. The density of the liquid may be considered as a constant, while that of gases changes with variation of pressure and temperature. The density of substance generally depends upon the temperature and pressure. The density of gas is proportional to the pressure, inversely proportional to the temperature. The liquids and solids, on the other hand, are essential incompressible fluids. The variation of them density with pressure is usually negligible. The specific weight or weight density weight density of the fluid is the ratio between the weight of the fluid to its volume. That is, weight per unit volume of the fluid is called as weight density. Specific volume of the fluid is defined as the volume of fluid occupied by the unit mass or volume per unit mass. The fluid is called as specific volume. It is expressed as meter cube per kg. That is, the specific volume is a reciprocal of mass density. It is commonly applied to the gases. Specific gravity is defined as the ratio of weight density of the fluid to weight density of the standard fluid. For liquid, standard fluid is taken as water. For gas, the standard fluid as air. The specific gravity, also called as relative density, it is a dimensionless quantity denoted as S. The specific gravity of the liquid is equal to weight density of the liquid, that is equal to specific gravity and weight density of the water. The specific gravity of the fluid is known, then the density of the fluid will be equal to the specific gravity of the fluid, that is multiplied by the density of the water. For example, specific gravity of the mercury is 13.6. The density of the mercury is 13.6 into 1000. That is 13,600 kg per meter cube. That let us be able to solve the one problem for to find the relation, to understand the relationship between the various properties. That is, calculate the specific weight, density, and specific gravity of the 1 liter of a liquid, which weights is 7 Newton. First, the volume is converted to the meter cube. Then the specific weight is equal to weight by volume, that is equal to 7,000 Newton per meter cube. Then density is calculated, which is a ratio between the specific weight to gravity. So specific gravity is equal to density of the liquid to density of the water. That is equal to specific gravity of the particular liquid is 0.7135.